Hi, we're the Bold Spots, and this is TouchTone Alert, a doorbell for all senses. I'm Amy.
I'm Kenzie.
I'm Lily.
I'm Bridget.
And our final design project is a TouchTone Alert doorbell. So our presentation is separated into four parts, with it being the problem, our approach, the process, and our final design. TouchTone Alert Doorbell is a simplified take on the modern doorbell. Instead of the video feed to alert users inside the house, TouchTone uses a speaker and light combination. Outside of the home, the same speaker and light combination alerts users that the doorbell has been rung. Featuring a touchless button design, TouchTone is perfect for users who prefer a less invasive home alert system. Our problem statement is we aim to enhance a conventional doorbell by integrating audio and visual cues to confirm when it has been rung, ensuring greater accessibility for individuals who are blind or deaf. Drawing inspiration from solutions like Ring, our approach does not include video capabilities. Instead, it emphasizes sound and light indicators to notify users of visitors at their door.
Beautiful. Okay, so the approach that we took to creating this touch-tone doorbell is we started by brainstorming and we looked at some of the really fun ideas that we could do and some of the really worst ideas, like we could do like a really, really loud, obnoxious doorbell that will ring every second or so. And then we narrowed it down to the components. So in our outside, we will have an ultrasonic sensor, which will act as our touchless button. And then we will have a speaker to act as the audio alert and an RGB light to act as the visual alert. And then on the inside, we will have a speaker, again, audio alert, light, visual alert, and then a button. And this button will be used to mute the speaker if for any reason you don't want to hear the doorbell ring. Next slide. Here are our components again. We have our speaker, our RGB light, our MP3, our ultrasonic sensor, our button, and our NRF24. So the NRF24 is our wireless data transmitter, and it enables the outside component to talk to the inside component. And this is crucial to the touch-tone alert system. It means that we don't have to have multiple wires running through the house. And for our prototype, it works really well. The MP3 is just the chip that we used to get the doorbell sound on our speaker. Ultrasonic sensor just senses distance, and we use that to act as a touchless button. The button we use on the inside to act as a mute button for users inside the house, and then the lights light up. Who would have thought? Next slide. Okay, so our final design. Again, we have the inside light, we have the outside light, we have the motion sensor, and we have our speakers. The motion sensor, what happens is that the user who's on the outside of the home will hold their hand in front of the, like close to, but in front of the motion sensor. And once it's held there for 2 seconds, this will activate the doorbell. So a light will go off inside and outside the house, and a speaker will go off inside and outside the house. The interesting inside component is our mute button. If the mute button is activated, if it's toggled on, then the inside speaker will not ring. So if you have like a baby sleeping, or if you're sensitive to sounds, but you still know someone's at your door, then you can still have a way by our inside light, but you don't have to use the inside speaker.
Next, we'll be talking about our process of our design. This slide shows the transmitter code, so the outside doorbell. The upper left-hand code shows the touchless button we created, so that when an object is in front of the ultrasonic sensor for 2 seconds, the doorbell is then activated. The bottom code shows that if the doorbell has been activated for longer than 2 seconds, then it will stop, basically, being on the light. So this is our transmitter code. This is our receiver code, which is the inside of our doorbell. So we have in these lines our if statement that involves our RF4, and then we have our toggle button code, which is lines 71 through or 69 through 72. Actually, it's the whole thing. And then what the receiver does is it will send, if the doorbell has been activated through the outside receiver or transmitter, it will send that code to our 24 on the inside, and it will send a 1. So if our data.door state equals 1, and the button is toggled, both the speaker will be activated and the light will turn green. This is the rest of the receiver code, which checks if the data.state variable equals 1, and if the button has been pressed, then therefore the speaker will not turn on, but the light will turn red. Else, then everything will be off, including the speaker and the light. Here are some pictures of our circuit. So the left diagram shows our inside system, which includes a mute button, a speaker, and a light indicator. This was a prototype of our circuit. So we have our MP3 connected to our speaker, which is then connected to the breadboard with the light and the mute button. Similarly, we have the outside system, which includes a speaker, a light indicator, and our motion sensor, which acts as our button. So when someone activates it using the ultrasonic sensor, the light and the speaker will act.
Okay, so now for our solution, as stated in previous slides, we have created the TouchTone alert system. Here are some photos of the inside and outside system of each box. The approach we took for building each box was using 3D printing, and we use software such as SolidWorks and Fusion 360. The box on the left is our outside system, and when it is activated by the ultrasonic sensor, the LED and speaker go off simultaneously. And on the inside system, which is on the right, it will go off as well simultaneously when activated from the outside with an LED and speaker. And the mute button is can be activated as well. And on Lily's screen, there is a demonstration now.
Okay, hey guys, back on my screen we have this one right here. This is our outside box, this is our inside box. Sound warning, it will be really loud, so just brace yourself. But what I'm gonna do is I'm gonna wave my hand in front of the motion sensor. And the bouncing back and forth that you hear is just our outside doorbell going off first, and then our inside doorbell going off. There's a bit of a delay because the NRF24s can't transmit instantly, because that would be kind of crazy. As you saw, both the lights went off, and then I'm gonna go ahead and toggle this red button right here. That click will switch off the inside speaker, and so when I ring it again, the light turned red to indicate that the mute button has been activated, so the sound will not go off, and you only heard the outside speaker go off.
And here is a video demonstration as a prototype, just in case.
Hello, it's Lily here. All that we did to the end is we added a toggle, so when the mute button is activated, we just add a little bit of an if statement to say that the toggle has been activated to indicate that the mute button is on, but the doorbell is not being run. So on its own, it looks like this. Doorbell is clearly not ringing right now, so the mute button is activated. Then I untoggle that. Nothing's happening, so I'm going to ring the doorbell. Let's see if I can get some view. Beautiful. Ring the doorbell. It's very loud. Brace yourself. Lovely. And then when I press that button, the light goes on and we'll activate the doorbell again. And then that light goes back on to indicate that it is muted. So, and then if I keep doing that, that's what keep happening. But yeah.
So this is the outside doorbell flow chart. If someone wants to say ring the doorbell, the hand timer will start, and if the hand is close enough, it will go into one out of the three options, which are if the doorbell has been rung already, make sure the timer state is started. If the timer isn't started, start the timer, and if the timer is started, keep track of the time that has passed. However, once the hand timer starts and the doorbell has been activated after 2 seconds, it will turn on the light, which will then turn on the speaker, or it will keep track of how long it has been activated for. Transmit the doorbell state to the inside of the house, ring for 10 seconds, then turn everything off, including the lights and speaker, and it will start at the beginning with someone wanting to ring the doorbell again. So this is the inside doorbell flowchart, otherwise known as receiver. So we start out by including the libraries, initializing pins, variables, data packets, unique addresses for the receiver, and finally unpacks all the data. Once it goes into the void loop, it will either read door state values or check the state of the button. If the current state of the button is low and the previous state is high, then that means the button has been pressed and toggle equals not toggled. However, if that is not true, then it will start over in the void loop again, and this same goes for the door state values. If the door state is 0 and toggle equals not toggle, then the LED will turn yellow. Otherwise, it will enter the void loop again. Say if the door state is 1 and toggle equals not toggle, then it will turn on the speaker and the LED will turn green. However, if that statement, whether the door state is equal to 1 and toggle equals not toggle, is false, it will ask if the door state is equal to 1, and if that is true, it will turn the LED red. If false, it will turn the speaker on. This is the circuit diagram for the transmitter. I have all the basic wirings of the NRF24 from Cobot. There's 3 10-ohm resistors connected to the RGB, with red connected to pin 3, green connected to pin 5, and blue connected to pin 6. There's also an ultrasonic sensor wired in here with tray connected to pin 8 and echo connected to pin 9. There's also a speaker with one end connected to ground and the other end connected to pin 10. So this is the circuit diagram for the receiver. Again, I have all the basic wirings of the NRF24 from the Cobot. There's 3 10-ohm resistors again connected to the RGB, with red connected to pin 5, green connected to pin 4, and blue connected to pin 3. There's a button wired to pin 2, and the speaker is wired to pin 10. So this is SolidWorks sketch of the outside doorbell system. There's a place for the ultrasonic sensor, LED, and the speaker. And this is the back of the outside doorbell system. This is SolidWorks sketch of the inside doorbell system. This square right here is for the button, this circle right here is for the LED, and this big circle here is for the speaker. And this is the back of the inside doorbell system.